This is Revisionary Test Examination 2025-26 HS second year sub physics theory. So I have selected only some of the important questions from this question paper, which will be helpful for you for your coming HS final exam. So here, which of the following graph correctly represents the variation of E as a function of 1 by R, where E is the electric field due to an infinitely long straight wire, due to an infinitely long straight wire. So the first important point here is that such type of graph is not given in your book, but you might have learned about spheres, how in sphere how electric field is the graph of electric field in a sphere, where we see that in a sphere, inside the sphere the electric field varies is directly proportional to r to the up to the surface. After that it varies inversely, but this is for sphere, but here this is for infinitely long straight uniformly charged wire, infinitely long chain, long straight wire. So here, what happens? We know infinitely. That means electric field at infinity is zero. Electric field. We know that the electric field, electric field at infinity is zero. At infinity is zero. So we start from there. Your electric field at infinity is zero. So we start from there, and so that becomes our initial point for uniformly for an infinitely long state, where that becomes our the initial point. So that initial point means for r, when you R is zero, when your R is zero, your electric field is also zero. Electric field is also zero. So we are considering that is from infinity. The charge is brought from infinity. As the charge is brought from infinity, your electric field will it means not the charge. That means we are coming from infinity, because we know that at infinity electric field is zero. So we are coming from infinity. That is considered as the initial point. So where for r is equal to zero, E is equal to zero, we are considering from the infinity. From that is the initial point from point. So as we move from infinity, your electric field increases. So your graph will be, this will be your graph. E versus 1 by r, your graph will be this. Your graph will be this straight line. Straight line. And if we go mathematically, we know that electric field uh, for an infinitely long straight wire is equal to lambda by 4 pi epsilon naught r. We know this. That is the, we have learned in Gauss theorem that electric field at a point electric field at a point for an infinitely long straight wire is lambda by 4 pi epsilon naught r, where lambda is the linear charge density. Lambda is your linear charge density, your linear charge density. You know about it. So here from this that means we take that E is your, that is equal to uh, proportional to 1 by r. E is proportional to 1 by r. So if we go mathematically, now if we take mathematically, it becomes like this: E is equal to lambda 4 pi epsilon naught into 1 by r. So you can compare with y is equal to mx. So here this is the slope, and this is 1 by r is x. So here it becomes a straight line. So the graph is graph will be, this one will be your graph. So the most important point here is that we are considering the infinity as the origin, because at infinity electric field is zero, and that is we are considering as origin. So as we move to as we move from infinity, your electric field increases. And if you go mathematically, so y is equal to mx means x is equal to 1 by r. So your graph will be a straight line starting from the origin. Starting from origin. Now the next question is, the potential difference applied across a given conductor is double the mobility of electrons in the conductor. The definition of mobility, that is the formula for mobility of a charge carrier. This is the mobility of charge carrier. This is your formula is charge of the electron, relaxation time by mass of the electron. Your formula, this is the relaxation tau, this is the relaxation time, this is the charge of the electron, and here this is the mass m. So here we find that the mobility, it does not depend on potential difference, where the here from the formula we find that the mobility is your mobility is is uh, independent of potential difference. So even if we double the potential difference, there is no effect in the mobility of the electron. So we can say that there is no change in the mobility of the electron. No change, no change in the mobility of the electron. We can say that there is no change in the mobility of the electron. Here, this is the relaxation time. Here, tau, this is called the relaxation time. Relaxation time. This is called the relaxation time. A constant magnetic field exists in a region along the direction. Magnetic field is in the direction from east to west. An electron moves towards north, enters the field, along which direction the field will exert force on it. Here we are going to use Fleming's left hand rule. We are going to use Fleming's left hand rule. Here we are going to use Fleming's left hand rule. The north, south, east, west. The direction of the magnetic field is from east to west. Magnetic field is from east to west, and electron moves towards north. That means electrons moves towards north. That means the direction of the conventional current, direction of the conventional current, conventional current, direction of the conventional current will be opposite to the direction of the electron. So it will be towards south. So towards it will be towards south. That means your middle finger will be towards the south. That means your middle finger will be towards south. Towards south, middle finger will be towards south, and the around force exerted, that is the thumb, force exerted force exerted, that is the thumb will point downward, will point downward. The thumb will force exert thumb will point downward. So this is the question on Fleming's left hand rule. Now the relation between relative magnetic permeability and magnetic susceptibility. This is your uh, relation between relative magnetic permeability and magnetic susceptibility. So here this is given 1.2 minus 1 is equal to, so 0.2. This is the magnetic susceptibility. This is your answer. Now next question is the electric current flowing in a wire in the direction from B to A is increasing. Find out the direction of induced current in the magnetic loop kept above the wire as shown. So here, this is Lange's law. Lange's law will be applicable here. So the magnetic field will be into the plane of the paper. Magnetic field will be into the plane of the paper, into the plane of the paper, into the plane of the paper. So the direction of the current will be clockwise. So the direction of the induced current, direction of the induced current will be clockwise. Will be clockwise. Will be clockwise. An object is placed in a medium of refractive index 4 by 3 at a depth of 4 meter. That means this is the real depth. Your real depth is 4 meter, and refractive index it is given to you. This is refractive index is given to you, that is equal to 4 by 3. You have to find the apparent depth. The formula for apparent depth is equal to real depth real depth by refractive index of the medium. This is the refractive index of the medium. So your real depth is 4 by 4 by 3. So this will be 3 meter. This is your apparent depth. This is given in your book. You will find in the paragraph at the last line the formula for it. There is no formula. It is not written in the formula, but it is given in a line. That is the your real depth is your apparent depth is equal to real depth by refractive index. Now here you see, this is a simple question. Radius of the nth orbit in Bohr model. Your nth orbit Rn is proportional to n square. This is proportional to n square. And next, a conductor of length L, means this is a conductor of length L, and your cross-sectional area is here. This cross-sectional area is A. So you have to derive this formula. So here you see N, it is the electron density, that is number of electrons per unit volume, per unit volume, number of electrons per unit volume. Vd is the drift velocity, small n, and total number of electrons will be n into volume, that is AL, air cross sectional area, into length, this will be the volume. And here your total charge will be NaLe. This will be your total charge, which charge of an electron is E. So for this much number of electrons, this will be your total charge. And the time required for the charge to move through a distance of L, because Vd is your drift velocity, velocity of the electron. So your time will be equal to this will be equal to L by Vd. This will be Vd. So I is equal to Q by T. So your total charge is this. So that is equal to NaLe, and your time taken is equal to L by Vd. So this will be equal to NaLe Vd. So you can write it as also this L and L cancels out. Sorry, cancels out. So you can write this as NeaVd. So this is your derivation. Now the next question, the value of magnetic susceptibility of a material is minus 0.2. Negative susceptibility is negative, that means it is a diamagnetic substance. It is a diamagnetic material. It is a diamagnetic material. And second, the magnetic field lines inside the material will be less than that outside. Magnetic field lines, magnetic field lines, uh, field lines inside the material, will be less than outside. Will be less than outside. Now the next question is, in a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of 2 into 10 to the power of hertz, and the amplitude, this is volt per meter, that means volt per meter, this is your E naught, 120 volt per meter. This is your E naught. You have to calculate the wavelength. So your wavelength will be lambda is equal to velocity of the light by frequency. This is velocity of the light by frequency. So this will be equal to velocity of the light, you know, that 3 into 10 to the power of 8 meter per second, and your frequency, it is given that 2 into 10 to the power of 8 hertz. Now if you calculate it, you will get the wavelength, that is equal to, in meters, you will get the wavelength in meters. And secondly, you have to find the amplitude of the magnetic field. So amplitude of the magnetic field B naught, that is equal to the electric field by the velocity of light. So you know that this is E naught is 120, and the velocity of the light, that is 3 into 10 to the power of 8 meter per second. So from here you will get the amplitude of the magnetic field, that is you will get in Tesla. Magnetic field, that is you will get the unit in Tesla. Now here your third question is, a parallel plate capacitor of plate area A, each and separation D is being charged by an AC source. So you know that you have studied in capacitor that the flux inside your parallel plate capacitor is that is charged by epsilon naught. That means charge. That means your this will be uh, charged by epsilon naught. You have studied in that is you have studied in uh, uh, capacitor. In you have studied in capacitor that the flux inside the parallel plate capacitor is charged by epsilon naught, and which it was derived from this uh, 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 plate that the flux at any point outside a charged plate, that is sigma by 2 epsilon naught, where sigma is your charge density. You have studied in Gauss theorem, and this is the flux inside a parallel plate capacitor charged by, that is a sigma by epsilon naught, that is the charge density. So here this is your q. Q is your charge by epsilon naught. Charge density means ultimately it is charged by epsilon naught. And you have studied that displacement current id, displacement current I, displacement current, this is equal to epsilon naught d phi e by dt. This is your uh, displacement current. Sorry, this uh, your displacement current, that is epsilon naught d phi e by dt. Now you place here phi, here you will get epsilon naught d uh, phi charged by epsilon, charged by epsilon naught dt. So this comes out to be dq by dt, and this is equal to I. That means mm, uh, inside the capacity is the same as the charging current. This is your charging current, and this is your displacement current. You have to show that your displacement current is equal to the charging current. Two lenses of focal length f1 f2 are in contact, so that the equivalent focal length f of the system is this. So this is the diagram. Uh, this is your diagram. So for here, uh, this is your object, and from here, this is your object distance, and now I1, this is your image distance for object u. This is your image distance. This is your image distance for object distance u. That means I1 is the image of the object, and it is a real image, and a real image, but uh, uh, here this I, it is the image of this object I1. Means I1, now it acts as a act as a virtual image, a virtual object. Virtual ob It act as a virtual object of the virtual object uh, and a virtual object and your final images and virtual object and the final image is I. So this act as a virtual object and your final image, that is V, this is your final image. So this is the figure, means uh, I1, it is the image of the object this, and it's a real image, but this I1 act as a virtual object, uh, and your final image is I. So this is your setup. That means I1, it is for your first lens. This is your for first lens, and I this is the virtual object for second lens. This second lens. This is A. Uh, this is your A, and this is your B. So this is your virtual object for, this is for your virtual object for your second lens. For your second lens, that is B. This is your virtual object for your second lens, and your final image is V. Final image is I. So you know the formula that 1 by V minus 1 by U is equal to 1 by F. This is your formula. So here 1 by V1 minus 1 by U is equal to 1 by F1. This is the focal length of your first F1. That is F1, it is for A, and F2, it is for B, focal length. These are the focal length. Focal length. These are the focal length. Focal length. These are the focal length. And this is equation 1. And for your second lens, this is your object and this is your image. 1 by V minus 1 by V1 is equal to 1 by F2. This. So when you add these two, 1 plus 2, you get 1 by V minus 1 by U is equal to 1 by F1 plus 1 by F2. So this is 1 by F is equal to 1 by F1 plus 1 by F2. This is your answer. So here this is a question. You have learned in Gauss theorem. In Gauss theorem, you have learned about it. For an sheet, uniformly charged sheet, electric field at any point is charge density by 2 epsilon naught. You have read about it, that is electric field. You have read about it, that is charge density by 2 epsilon naught. So here your electric field, that is your charge density 8.85 micro, that means 10 to the power of minus 6, and charge, that is 2 into 10 to the power of minus 9. So this comes out to be, let me do the calculation. This comes out to be, that is 10 to the power of 6 by 2, that is 5 into 10 to the power of Newton per Coulomb. So this comes out to be 5 into 10 to the power of uh, uh, 10, this 5 into 10 to the power of 5 Newton, 5 Newton per Coulomb, and your F is equal to Q into E. So charge of an this is the charge it is given to you, 2 into 10 to the power of minus 9, and electric field is 5 into 10 to the power of 5 Newton per Coulomb. So this comes out to be 10 to the power of minus 3 Newton. So this comes out to be uh, 10 to the power of minus 3 Newton, and your acceleration that it will be equal to F by m. F that is equal to 10 to the power of minus 3. 1 gram, that means 1 by 1000 kg. So this will come out to be 3, that means 1 meter. Your acceleration is 1 meter per second, 1 meter per second square. So your speed is v is equal to, initially at time t is equal to 0, means at t is equal to 0, at time t is equal to 0 initially. Let us consider that your velocity, initially velocity is 0. So u plus at, let us consider this initially 0. So 1 into u here 5 second, for 5 second into 5, that is 5 meter per second. This is your answer. This is your answer. This is a Gauss theorem for a sheet that is a flux, that is a phi phi that is equal to E by flux. That means what is flux? E into area, that is electric field. After all, flux, that is also electric field. So that is a flux, electric flux, that is equal to sigma, that is charge density, by 2 pi epsilon naught flux. That means after all it is an electric field. So this is your electric field. In this question, a long straight conductor carries a current this. So what will be your magnetic field? You have learnt about it, mu naught I by 2 pi r. That means your, this is your straight conductor. Current is flowing through it. So magnetic field at any point P at a distance r, you have you know about it. We have derived it also from this Ampere circuitry law. Also, we have taking a circular loop. We have also derived in Ampere circuitry law. Magnetic field is equal to this much. So you have to take this formula, and force, for force you know that F is equal to Q, that is V cross B. So this is here, that is equal to Q V B sine theta, sine theta. 4 meter starts moving with a speed, a proton, that is this, opposite to the direction of current. The conductor, as shown in the, calculate the force acting on the proton. So that is nothing else, that is your this V uh, velocity, that is VB, V cross B. This is the velocity of the charge. So V and I, they are in the same direction. V and I, they are in the same direction, means proton. And here your B, VB, that is angle between, the important point is, sorry, V and I are parallel. Sorry, V, velocity, this velocity and I are parallel or anti-parallel. What if this is anti-parallel, because it is moving in opposite direction. As per the figure, it is anti-parallel because it is moving in opposite direction, V, velocity and I. But the angle between V and V, but the angle between between V and B is 90 degree. Angle between V and B is 90 degree. So from this figure, this V and the current, they are in, they are anti-parallel. So that means, and the angle between V and B will be so 90 degree. So this will be equal to QVB sin 91. From here you will calculate the value of B, and you put the value of B here. V, it is given to you, and charge, that is charge of a proton, you know that is equal to the charge of an electron, and if you place here, you will get the force. You will get the force acting on it. Now here, this is a question, that is, use a mirror equation to deduce an object placed between F and 2F. Concave mirror, this is your concave mirror. Concave mirror, object is placed between F and 2F. F, 2F. Here, this is your object. This is your U. So mathematically, that means U is greater than F, less than 2F. So if we apply mirror formula, that is 1 by V plus 1 by U is equal to 1 by F. So this is 1 by V, 1 by minus U is equal to 1 by minus F. So 1 by V is equal to 1 by U minus 1 by F. So 1 by V is equal to UF, F minus U. So here V is equal to UF, F minus U. So here you see that V, that means F, since F, here since F is less than U, so F minus U is less than 0. F minus U is less than 0. So here your V is equal to UF by F minus U is less than 0. V is negative, that means real image. So this is a real image. This is a real image. This is a real image. Now, let us take this magnitude is equal to UF by F minus U. So this is magnitude. So this will be UF. We can write this like this, U minus F. We can write this like also. We can write this like this. Now here it is given to you. You have to uh, that an object placed between this of a produce a beyond 2F. Beyond 2F. That means your modulus V is greater than 2F. Your modulus V is greater than 2F. You have to prove this. So I am going to move in a reverse direction. That means you have to this. You have to prove this. You have to prove this. This is proof that. This is proof that. But I am going to take, to prove this. I am going to take. We will. I am going to take this as a given, and we will come to the. We'll take this as given, and from here we will come to the. We'll show that U lies between this and this. We will take this as a given, and we will come to this point, that is, we'll try to prove that U lies between this and this. And it is like the one which we do in earlier classes. In class 10 you have done to prove root 2 is irrational. So what we do, we take root 2 as rational. So if the procedure is somewhat like this, uh, we take this given and we'll try to prove that U lies between this and this. So how to do it? So here, this is modulus, this is UF uf by u minus f is greater than 2f. So here you see that u by u minus f is greater than 2. So here u greater than 2u minus 2f. So here minus u is greater than minus 2f. So u is less than 2f. So here we have shown that u is less than 2f. So we know that when the object is between f and 2f, then your image is beyond 2f. So here you see that our initial condition is initial condition is satisfied. So I'm closing here now. This is my last question, and I'm closing here. Today, I have selected only the important questions which will be helpful for you in your coming HS examination. This is all for today.